to control the CO2 level and discharge. Like, no, let's say if your wind speed is blowing from this direction to this direction, so up to 6 meter per hour, something like that, we try to stop CO2 supply. Otherwise, in open atmosphere, what is going to happen? If you are releasing CO2 and air blowing is coming, until or unless you close to, there will be unnecessary uh, kind of CO2 loss. To check that, so we develop the logic control such a way. Let's say if it is 6 meter per hour, if it is exceeding, your CO2 supply to be stopped, like, your solenoid controlling action to be stopped. Again, the wind speed comes down, again the CO2 release will be taking place. And number one, this is going to avoid CO2 loss. And contrary, if wind speed is moving from this direction to this direction, automatically this CO2 release valve will be open, CO2 will be released from this direction. So the main intention is to maintain CO2 level in this particular area based on the set point, either it is 650 ppm or 700 ppm, whatever level you set. Now, those variable factors we have taken into consideration while developing the software, our PLC control software, because here everything, because when you give a system command, let's say you want to maintain 650 ppm, so you have analyzer. Analyzer is going to analyze what is the existing CO2 level. If it is less, your CO2 supply will be taking place, your solenoid valve will be open automatically and CO2 release will be there. Once it achieves CO2, the required level, CO2 supply to be stopped. Similar way, anemometer also playing those role based on different wind direction. So opening and closing of different arms, it is controlled through the anemometer signal, because each signal is taken into the PLC and the logic control and everything is been set up over here. So accordingly we have developed our software such a way, and along with the data logging part also is there. We have the complete data logging of system, so that whatever real-time data is been stored in Excel form. We have developed various free air CO2 enrichment system. This is we have developed for Dr. M.S. Swaminathan Research Foundation, Chennai. We have done it for, again, this project we did it for NBRI Lucknow, and it's a CSI Research Institute. There are many rings around this area we have developed for them, and there is a group of scientists there involved and doing various research activities. So either it is biotechnology, microbiology, plant physiology, molecular biology, all those plants have been exposed to high CO2, high temperature and ozone level for conducting various research. This project we have done it for ICRISAT, this is International Research Institute. They are mostly working on legumes. So this project, if you see, there are only pipes there, but the releasing everything is in control through the control room. Externally you won't find many things, because it is taken from underground. Your CO2 release pipes, everything is taken from underground to the control room. Even signaling, everything has been taken through cable tray, through Wi-Fi communication system for controlling and data logging purpose. This we have done it for JNU, Jawaharlal Nehru University. You can see this is the ring, CO2 has been released through pipes, and this is the anemometer for controlling the CO2 level. So this project we did it for ISBT Palampur. It's a CSI Research Institute located in high altitude. So this is the project we have done it for Dr. Ramesh Swaminathan Research Foundation. Dr. Swaminathan, he came personally and inaugurated this project. This is almost 7 years back we did this project. So far we have done many projects on 3-year CO2 enrichment system, starting from ICRISAT, IRI, NBRI, JNU, ISBT Palampur, and MS Swaminathan Research Foundation. So the interesting part is most of the projects are in working conditions. We are supporting them on time to time basis. Now I am going to talk about another technology, that is free air temperature enrichment technology. First we have talked about free air CO2 enrichment. This is the free air temperature enrichment. Now the question is, you can have a single system where both CO2 and temperature can be integrated. So that is going to reduce the cost too. So but if you want to have only the temperature part, you don't need to CO2 ring, then you need to have only free air temperature enrichment facilities. Now let me explain to you. The same way free air temperature enrichment is a technology used to create artificially induced uniform temperature in open field conditions. The system is based on series of microcontroller with IR heating system. Now this is the schematic over here. You can see is a hexagonal ring. You have mounted the IR heater, infrared heater. It's a ceramic heater, either it is 500 watt or 1000 watt heater. Ceramic heaters we are putting, either it is vertically or horizontally we are putting, and we are also keeping your temperature, humidity sensor, CO2 monitoring system inside the ring. And the way we have done for phase system, same logic control one can use for controlling the temperature and CO2. This ring can be used for both CO2 and temperature controlling purpose. So if you see that we have done various FATE project for many institute. This is the project we did it for IRI, Indian Agriculture Research Institute, that is Agricultural Physics Department. This is the infrared heating with adjustment, like height adjustment option. They are working on various crops like wheat, rice, and many other crops. So when the seedling grows, they try to bring down the IR heating system little lower so that plants to be exposed maybe ambient plus 2 to 3 degree. Then accordingly the height adjustment can be done. So this is the project. Still this project is in operation. Almost 7 years back we did this project for IRI. This is for MS Swaminathan Research Foundation, Chennai. For FATE system we have done, it is 8 years back. This is a typical control system for phase, FATE, OTC, any technology. Here basically the data logging system. This is the PC. You have the light where the power supply for many other signal that is going for indication light. You have analyzer is mounted over here. So basically from this control panel you can set your all parameters which is required to do the experiment. This is again we have done it for ISBT Palampur with the IR heating system. You can see it, infrared heating system, how it is mounted. So we have done few projects for 3-year temperature enrichment at IRI, ISBT, and MS Swaminathan Research Foundation. And we have recently did it for NBRI too. So this is not included the NBRI, also National Botanical Research Institute CSIR project we have done. So this is a kind of a very interesting project. We did it for IRI, free air CO2 ozone enrichment technology. So ozone is a also an important gas now for research purpose, because of ozone depletion. What scientists are trying to see the impact of ozone on various crops. So how it is affecting the photosynthesis, their physiological biochemical activities, how it is changing by different exposing plants in different ozone level. We have developed 6 rings over here, and we have tried to discharge ozone into each ring in different ozone level. It's starting from 60 ppb to 150 ppb in each ring, and also along with that we have a ozone generator. Which ozone is generating, we have tried to put a blower and try to discharge ozone into each ring. Now you have also CO2 cylinder. From the cylinder we are also discharging CO2 in each ring, because there are 2 lines that is going. Now out of 6 rings you can have different CO2 and ozone level maintained, and accordingly you can have the complete experimental design. Setting of all those parameters can be done through the PC, the PLC that has been inbuilt. So this project we did it for Center for Environmental Science and Climatic Resilient Agriculture, Indian Agricultural Institute, IRI, that is New Delhi. And this we did it for almost 7-8 years back. This is the actual photograph of this project. This is the duct line for releasing ozone into those chambers, the basically the rings. So there is duct line, you can see. This is the view of those rings. Now I'm going to talk about another important technology, that is free temperature gradient tunnel, TGT. This technology has been used for both temperature and CO2, creation of CO2 and temperature gradient inside the tunnel. This is a very interesting technology, and those technology are being used by scientists for various applications, screening of germplasm of different plant varieties which are capable to grow the most suited conditions they want to check. Let's say I will come back to this particular technology. This is basically a tunnel of 15 meters to 60 meters, and it can go up to 70-80 meters. There is no problem, you can do those things. Now the question is, the length can be of any size, width can be 3 meter, 4 meter, height can be 3.5 or 4 meters. Now the technological part is something like that. Here you have the air blowing facilities attached to an infrared heating system. When you try to blow hot air along with the air inside the tunnel, it travels across the tunnel, and the gradient atmosphere creates inside the tunnel, and we have mounted temperature and CO2 monitoring system every 3 meters, and we are also purging CO2 from one direction to another direction. CO2 release also is there, and a gradient profile is created artificially. And once you are growing a similar kind of crops inside the tunnel, so those seedlings, once they grow, they are exposed to different CO2 levels. So same crops, once it is exposed to different CO2 and temperature level, it is going to respond differently in respect to temperature and CO2 level. What I'm trying to tell over here, let's say if you are sowing the seedlings, once it is growing, now already you have the gradient atmosphere created inside the tunnel every 3 meters. Imagine a situation you have 25 meters or 30 meters tunnel, every 3 meters, like you have 10 gradient atmosphere created inside the tunnel, and every 3 meter you have temperature CO2 monitoring and control system. And when it is monitoring, you can easily see that the variation of growth pattern of those plants, your flowering, your productivity, your photosynthesis level. Now you can screen which temperature and which CO2 level is best suited for that particular crop. It is easy to select the best crops in a particular CO2 and temperature level. So CO2 gradient atmosphere created inside the tunnel, it is helping in a way that in one go you can screen it, right? This project we have done it for IRI New Delhi. This is for again for agricultural physics department. This we have done it for NRRI, that is National Rice Research Institute, Kotak. This is IIVR, Varanasi, Indian Institute of Vegetable Research. We have done it for 8 years back. Now they are also using this system, and we are supporting for them for a long time. They are using this system for developing different varieties, mostly for vegetables. So we have done it for Assam Agriculture University, IIVR, IRI, and CRRI, Central Rice Research Institute, Kotak. Almost 14 system we have developed. Apart from this thing, as I have told earlier, that we have done system for EquiSat also. Last year we have done EquiSat project for, it's a very big project for CO2 temperature gradient tunnel. We have given 2 tunnels for them. It is close to 22 meters length, 3 meter height and 3 meter width. 2 tunnels with complete wireless communication system, both CO2 temperature monitoring and control facilities with infrared heating system. This has been provided for EquiSat. Now coming back, there is another important technology I am going to talk about for a specific application. This we have done it for ISBT Palampur. It's a CSI Research Institute. This is an elongated tunnel for stress studies, right? You can literally see a polycarbonate like a train compartment. You can see there are many compartments. I'll come back to you the theories and the application behind this project. So okay, now let me come back to this schematic. Here you have 1 2 3 4 5 6 7 compartment, like a train compartment. It can 12 feet, 3 feet by 3 feet. It is 3 meter height, 3 meter width, and close to 5 meter length, like. So now those compartments are interconnected. Now what is happening, like this project is developed taking a paper from journal Elsevier. So the objective is when you go high altitude, because this institute is located in high altitude as a Himalayan belt. So they are working on medicinal plants. They are growing, they are collecting different medicinal plants from different altitude. They want to seek, because once you go the high altitude, your CO2 level and oxygen level also it it varies. So it comes down to the below ambient level, because in normal atmosphere your CO2 level 380 ppm. If you go up, it comes to maybe a little less. So their objective is to create a stressed condition, maybe 330 ppm to 320 ppm kind of atmosphere. In these stressed conditions, they want to see the how plants are responding, because it is very difficult to go to the high altitude and check what kind of those atmospheric conditions carry out the plant physiology or biochemical activity studies there. Now in one platform, like, what they are trying to do is they're trying to purge air from one direction, and you have complete CO2 temperature monitoring facilities inside this thing. Now if you are purging CO2 of 380 ppm over here, you are growing plants here, all those chambers you are growing plants. Now if you are purging the same here, 380 ppm, once it is coming to this compartment, your CO2 level is coming down again, it is further coming down, and the last compartment will have the least CO2 level. Now because of the lowering the CO2 level, when plants are not getting enough CO2 for their photosynthesis, it is indirect stress is created, and they want to see that how this is impacting the plant growth and responses. So we made this project for them. Those tunnels we have made for them with a complete controlling and automation facilities. The system is inbuilt with CO2 monitoring system, RH, temperature, humidity, and power, and it is connected to a computer with complete monitoring and control option. This system we have provided for them. This is the actual photograph with the drip irrigation facilities, and those are the tunnels, and your temperature also is being controlled here. We have provided the cooling system here. The cooling system we have provided to maintain the temperature. Now I am going to talk about another interesting technology, that CO2 elevated bioreactors.